All right, so today we're in sections 1.1, or 1.2, and 1.3. You say, oh my goodness, you're doing 2 sections in one day? Don't worry, we got through it last hour with plenty of time to spare for the homework, okay? Because you already have learned the first part of it, the integers part, just no decimals, no fractions, so that part will be review. All right, but to start off, sometimes we have these important words, and especially the first one, this additive inverse. You're going to hear me referring back to it in the lesson today. This whole idea of the opposite of any number. And more specifically, don't you guys love shortcuts? Anybody just love the long way? You just take the long way anytime you can, right? We like getting to the answer as fast as possible, unless you just love doing math homework and spending lots of extra time, right? So the additive, obviously sarcasm there. The additive inverse property, okay? So number properties sometimes look scary and like really wordy, but really what it means is it's going to make your life easier. If you can pick up on additive inverses and it's in your homework tonight, and when you can like come up with the answer in a fraction of the amount of time, okay? So that's what we're trying to do. Now, rules for adding integers. We have this saying. You gotta help me out, okay? Yes. Okay, so we have a nice little catchy saying that we like to say, okay? It's, I'll say it once, and then I'll start to sing it, and then you're gonna sing it with me, because I'm not a singer, all right? So it's same sign, add and keep, different sign, subtract, take the sign of the larger number, then you'll be exact. The words are up here, so you're gonna follow the tune. Same sign, add and keep, different sign, subtract, take the sign of the larger number, then you'll be exact. All right? I know, it's so cheesy, and I don't sing it great, but I promise you, and we're going to sing it more too, not on the YouTube video. Thank God. No, that's on the internet. Oh my goodness. Okay, so what is the idea here? If 2 numbers have the same sign, both negative or both positive, we add them together and we keep the common sign, add and keep. Different signs, we subtract them and we take the sign of the larger number. Then you'll be perfect, okay? All right, here we go. Okay, so here we have adding integers. The first question you're going to ask yourself, and this is across the board, you're going to hear me saying this all week. Do we have same sign or different? What are our signs? Okay, so -4 plus -2, is that same sign or different, guys? Same. They're both negative. So we add them and keep the common sign, -6. -6. Okay, what about 5 plus -10? Is that same sign or different? It's different. Okay, one is positive. Now look, guys, 10 is negative. That plus sign is actually irrelevant. All right, we're going to talk about double signs here in a minute. Okay, 10 is negative. Different signs subtract. What's 10 minus 5? 5. Take the sign of the larger number. That's absolute value. So because 10 is bigger, your answer is negative. Is this coming back to you guys? Okay, so your answer is -5. I want you to go ahead and finish the rest of them. Okay, finish the rest of them. Just trying to warm up to adding integers. Okay, what's 8 plus -4? 4. It's positive because 8 is bigger. All right, what about -5 plus -10? -15. -15, good. Same sign, add and keep. -3 plus 7? 4. And -15 plus 8? -7. Awesome, guys. All right, questions on integers. Okay, so now we're going to delve into the world of rational numbers, starting with fractions. Okay, so what do you need to have? You have to have this before you can add or subtract fractions. You have to have something. All right, Joel, do you know? You're close. A common denominator. An LCD is what we're going to call it. So LCD is important. We need an LCD, okay? So are we ready to add these fractions or whatever we need to do? Are we ready to do that? No, we need an LCD. So that's the first thing. Which fraction needs to change?
8 over 3.
8 over 3. We're not going to worry about the negative yet. We just need to get our denominators the same. The negative will not have any effect on how we change this fraction. So 8 over 3 changes to make the denominator a 6. And what's my new numerator?
16.
A 16. Okay? And that is negative. Okay, so now, just as a review also, when we are adding fractions, do we add the denominators together? 6 plus 6?
No.
Is that our rule? No. We just bring it across into our oh, what did I do? What's up? Okay, 16 because 3 times 2 is 6. So 8 times 2 is 16. You have to multiply by the same number top and bottom. Okay, good question. All right, so now, guys, we've established we're going to bring our 6 across, and now we need to combine our numerators. What's negative 16 plus 5?
21. Negative 11.
Negative 11. And that's going to be my answer. I know it's kind of squished over there, so I'm going to rewrite it. Negative 11 over 6, and you can leave it improper as long as it is reduced all the way. Just leave it improper. Don't change it to a mixed number, okay? Just leave it just like that. So find our LCD, and then we'll use our rules for positives and negatives to combine the numerators, all right? Okay, let's see. Oh, I kind of really got right up on that one. So, all right, let's look at the next one down. Negative 1 3/8 plus 5/4. What do we see that's different here? Different denominators and a mixed number. All mixed numbers, and this is just easy to just say across the board, we are going to change to improper fractions. Again, the negative, we're going to pretend it's not there when we're converting it. Okay? So what is 1 3/8 as an improper fraction?
11.
Okay, I heard it. 11 over 8. Now bring down the negative. So negative 11 over 8. Does everybody understand? We don't include the negative when we're changing our fractions. Okay? So negative 11 over 8 plus, ooh, I need to change this one. Right? Because I need my denominators to be common. Can we make a 4 into an 8?
Yes.
Okay, what did we have to multiply by?
2.
So what's 5 times 2?
10.
Okay? And I'm just drawing those arrows so you see kind of what we're doing. You don't have to draw those arrows, okay? But we have to have our LCDs. So now that we have our common denominators, now we can combine our numerators. Go ahead and finish that one. Combine your numerators. All right. Same sign or different? Different, right? So what do? Subtract and take. Negative 1/8. Did you get negative 1/8?
Yes.
Did you get it? Okay, I want you to do this top right one on your own. Am I ready to combine these fractions? Am I ready? Do I have an LCD?
Yes.
Yeah, my 2's, right? So now focus on the numerators. Same sign or different? Same. They're both negative, guys. Okay, you've got to look at that sign in front of the number. They're both negative. Negative 1 plus negative 3, same sign, add and keep. Negative 4 over 2. Am I done? No, that can be reduced. Negative 2. If you said negative 2 over 1, that's fine too. Okay, so you need to reduce when you can. All right, whole numbers. What can I do with 4 to make it match up a little better with 7 over 2? Okay, can I start with 4 over 1?
Yes.
Plus 7 over 2? Ah, but I need this bottom number to be a 2, so what do I multiply it by?
2.
2, so what do I multiply the top number by?
2.
So 8 over 2, everybody in agreement?
Yes.
Plus 7 over 2. Got my signs right? Oh, I don't. Ooh, what did I do wrong? Okay, forgot that 7 is supposed to be negative. All right, I'm going to erase this one. I'm not going to squish it together. Think I did that one on purpose? No, I forgot the negative. You always have to go back and check. What's 8 minus 7? All right, did you get 1/2? Okay, so do you see how my positive and negative rules tie directly into fractions? So the same thing is going to happen with, what do you think the next slide is? You can see it. Decimals. Okay, so I'm going to use my decimal rules. Okay, and my number one rule for adding and subtracting decimals is I have to line up what? Line up the decimals. Okay, so I'm going to use those rules and use my positive and negative rules to simplify these expressions. Okay, first question, same sign or different? Same, okay? So as soon as I know same, I know I'm doing what to these numbers? I'm adding them. Forget the negatives for now, okay? So come over here to the side. This is where you're going to show work, okay? 1.5 plus 0.75. Make sure you line up those decimals. Placeholder with the 0. You just told me because it was same sign, you're going to add together their absolute values. That's what we're doing here. Okay, go ahead and do that. Add those decimals. Okay, what did you get? Yes. 2.25. Now this is where the sign comes back into play. We said we're going to add their absolute values and keep the common sign, which was what? Negative 2.25. Okay, you see where that came back into play? All right, because they were both negative, I add them together and keep the negative. All right, so I want you to do this second one on your own. When you have the answer, I want you to raise your hand. All right, so same sign or different? Same. Okay, so I add them together, 3.3 plus 2.7, and I know that's 6.0. Is it positive or negative? Negative. It's going to be negative. All right, let's go over to the second column. Is this same sign or different? Different. It's different. So what am I going to do now? Subtract. And subtracting decimals, order matters. You hear me? All right, listen up, guys. You have to put the larger absolute value on top. If you try to say 4 minus 5.35, you're not going to have enough value in your place values to do that subtraction. Okay? So you have to put the larger absolute value on top. You just told me it was different sign, so we subtract. Okay? So when we subtract it, we get 1.35. Now here's my question. Is my answer positive or negative? Okay, can anybody tell me why it would be negative? Anybody tell me? Jack? Yes, very good. Because you go back to the original expression, 5.35 was the larger absolute value. Your answer is negative. Okay, do you guys see how we did that? All right, last one, same sign or different? Different, so what do I need to do? Subtract them, make sure the larger absolute value goes on top. 1.65 minus 0.9. And then put a 0 in there too to hold the place. Okay, go ahead and subtract them. Double check the sign of your answer. All right, what'd you get, guys? Oh, I'm hearing some different. Okay, so we subtracted the 5. Then we got a 7. Is it positive or negative? Positive. Positive, because 1.65 was bigger. All right, so we've knocked out the integers, the fractions, the decimals. Okay, now let's talk just for a quick minute about double signs. Okay, we're going to start getting rid of these. You will see them on your homework tonight, but we're going to get away from double signs pretty quickly. All right, this whole plus a negative thing right here, that's the same thing as minus. It's the sign that belongs in front of the number that we keep. Okay? All right, so 10 minus 4, same thing. They both equal 6. Okay? 15 plus negative 5, that's the same thing as 15 minus 5. They both equal 10. All right? Plus a negative is the same thing as subtracting. All right, here's where it affects your answer. What we call a double negative. two negatives back to back without a number in between. You say, well, there's parentheses there. The reason it's there is to separate a double sign. A double negative equals a, what does the note say? A positive. You must change it. You can't look at this one and say, oh, this is different signs. 6 is negative. That double negative makes 6 a positive, and now my answer is 11. Okay, so I need you to just kind of put that in the back of your mind for tomorrow, because tomorrow you're going to see a ton of double negatives. Anytime you see a double negative, it will change to a positive. Are we clear on that? The plus the negative, you can kind of, get away with if you miss that. But the double negatives, we always have to change to positive. Okay? All right, almost done. Okay, all right, so this one's going to be like a bank type of example. All right, so when you put money in, you call it a, what, look at the table? A deposit. So that's positive, right? You're putting your money in your bank account. When you take it out, we call it a withdrawal. Okay? And I'm going to throw out a kind of a commutative property, okay? Says that I can actually arrange these values in any order I want to simplify them. You guys remember when I was talking about that additive property? What did we say? Additive inverses? As soon as we see multiple, I'm talking like 3 or 4 or 5 or 6 terms, and I'm going to throw them in there, and it's going to look like the most obnoxious problem you've ever seen, okay? You're looking for these shortcuts. Do you see any values here in this table that the additive inverse property could apply to make this easier to find our ending balance? Yes, what do you see?
The $50 deposit and the $50 withdrawal.
Right? You put $50 in and you take it out. Those cancel out. Okay? So it's asking us, all right, to find an ending balance. If I take out $40, and I do want you to write this, and I add $50, I deposit $50, then I deposit $75 more, then I withdraw $50. All right? Now, there's a couple ways I can do this. I can just work left to right. Negative 40 plus 50 plus 75 minus 50. Sometimes you might have to do that. All right? And we'll talk about different ways different strategies. But this lesson in particular wants us to focus on the additive inverse property. Like he said, my 50s cancel. And now I'm just left with negative 40 plus 75. All right, I know it's different signs, so I can subtract them. You can show your work if you need to get an ending balance of positive $35. So that's good, right? I still have some money left over. That's all it's asking. All right, so really what we want to focus on here is catching those opposites to make it easier to solve. All right. Okay, so we're running kind of short on time because that supply check. So the last example is kind of more the same thing. I'm going to do it a little quicker than I did in the last class. Again, we're looking for gains and losses, guys. So the table talks about a business. In 2013, did they make any money? Negative $1.7 million. Now, before you think that they're like a huge failure, that's pretty common when you're starting a big company. Now, this is huge, to not make money the first year. The second year, something really went wrong, okay? And then they kind of have a bounce back here. And here's what the question says. Over a 5-year period of time, which one of these 4 options describes their profit? Okay? So, what did I just tell you was the first thing we want to look for? Before we start just adding and subtracting all these numbers.
Things to make it easier.
Which is?
Negative 1.7 and 1.7.
Look for those inverses, guys. You see them? Okay. So now we have a profit. You made $4 million and they lost $4.75 million. So are they in a gain or a loss?
Loss.
They're in a loss. So I have 2 options here. They either lost 75,000 or 750,000. I need to know how much 0.75 of a million is. Does anybody know? Jack? Yes, $750,000. Okay, it would have been 0.075 if it was 75,000. Okay, so that's kind of tough, right? That's a lot of money. It's a little bit more than I make, right? Okay, that was kind of funny, right? Okay, but look at this profit in 2017. They actually did pretty good. So you think if they went one more year, they actually might be profitable based on their growth? Yeah. 6-year turnaround for profit is kind of tough, but if you're talking you're going to be making millions and millions of dollars, it might be worth it. The first 5 years might be stressful, though. You see how we kind of made that conclusion based on just some random numbers in the table? Okay? So I know that part gets kind of hard, but we'll try to kind of have that dialogue and open it up. You have a couple on your worksheet tonight. But for now, we're going to, again, because the supply check, we really just don't have time for Think, Pair, Share. We're going to jump straight into the worksheet for homework tonight so we have time to really work on that together. Okay? And that'll be it.